Thank you for coming to Space Story. Please click subscribe, like, and notification. Universe Story. 10.2 billion years ago, 10.1 billion years ago. From approximately 10.2 billion years ago to 10.1 billion years ago, the universe underwent a period of intense change and growth. The relatively young universe after the Big Bang was still experiencing active star formation and galaxy evolution. This period provides a crucial key to understanding the early stages of the vast and complex cosmic structures we observe today. 1. Peak of star formation. About 3 billion years after the birth of the universe, this era is considered the peak of star formation rates. Massive gas clouds relentlessly gave birth to numerous stars through gravitational collapse. These early stars were much heavier and hotter than the stars we see today, and many ended their lives in violent supernova explosions. These supernova explosions released heavy elements into space, becoming the raw materials for subsequent generations of stars and planetary systems. 2. Galaxy growth and mergers. The early universe contained many relatively small and irregular galaxies. Drawn together by their mutual gravity, these galaxies constantly collided and merged, gradually growing into larger and more regular forms. The process of galaxy mergers promoted the birth of new stars and also induced the growth of supermassive black holes at the centers of galaxies. During this period, galaxies with the early forms of today's giant elliptical or spiral galaxies slowly began to appear. 3. Quasar activity. At the centers of some early galaxies existed quasars, which emitted extremely bright and powerful energy. A quasar is a phenomenon that occurs when a supermassive black hole at the center of a galaxy rapidly absorbs surrounding matter. In this process, enormous amounts of light and radiation are emitted, making them observable even from the distant universe. The period from 10.2 billion years ago to 10.1 billion years ago was a time of relatively active quasar activity, believed to have played a significant role in the evolution of early galaxies and the growth of supermassive black holes. 4. Early stages of cosmic web formation. Due to the action of gravity, dark matter and gas gradually began to separate into denser and less dense regions. The denser regions became the seeds for the formation of galaxies and galaxy clusters, while the less dense regions developed into vast empty spaces, voids. This period marked the beginning of the formation of the cosmic web, a structure resembling a giant spiderweb. Conclusion. The period between 3 and 4 billion years after the Big Bang, 10.2 billion years ago, 10.1 billion years ago, was a crucial turning point in the universe's evolution, characterized by explosive star formation, dynamic growth and mergers of galaxies, and the prominent activity of quasars, powerful energy sources. The universe during this time played a decisive role in forming the fundamental framework of the complex and vast cosmic structures we observe today. Scientists are currently working to unravel the secrets of this early universe through various observational instruments and theoretical research. Universe history. 10.1 billion years ago, 10.0 billion years ago. From approximately 10.1 billion years ago to 10.0 billion years ago, the universe gradually began to stabilize amidst the turbulence of the previous era. The once active rate of star formation slowly began to decline, but the galaxies that had already formed evolved with more distinct structures. Even within this short period of 100 million years, the universe continuously changed, moving one step closer to the universe we know today. 1. Decline in star formation rate. In the early universe, the abundant supply of gas gradually depleted, and changes in the internal environment of galaxies caused the star formation rate to pass its peak and gradually decline. However, new stars were still steadily being born in many galaxies, formed from the remnants of previous generations of stars and newly condensed gas. 2. Diversification of galaxy morphology. Through active mergers and evolution, the shapes of galaxies became more diverse. Galaxies with distinct spiral arms, round and smooth elliptical galaxies, and galaxies still maintaining irregular shapes began to coexist. Within galaxies, the distribution and rotational speeds of stars gradually formed stable structures. 3. Decline in quasar activity. The active quasar activity of the early universe gradually subsided. This is believed to be due to a decrease in the supply of matter around the supermassive black holes at the centers of galaxies or changes in the activity cycles of the black holes, leading to a reduction in powerful energy emission phenomena. However, quasars were still observed in some galaxies, and they significantly influenced their surrounding environments, playing an important role in galaxy evolution. 4. Growth of cosmic web. The action of gravity worked over longer periods, making the cosmic web structure more distinct. Galaxies gravitationally attracted each other, forming groups, and these galaxy groups formed vast, filament-like structures. Between these filaments, vast spaces of low density, or voids, became more clearly apparent. Conclusion. The period between 4.0 and 4.1 billion years after the Big Bang, 10.1 billion years ago, 10.0 billion years ago, was a time when the turbulence of the early universe somewhat subsided, and galaxies evolved into more mature forms, with the basic framework of the cosmic web becoming more distinct. Although the star formation rate decreased, the various types of galaxies that had already formed continued to evolve in their own ways. And while quasar activity declined, it still influenced the universe. This 100 million year period provides an important link in understanding the complex and beautiful appearance of the universe we observe today. 51. Universe history. 10.0 billion years ago, 9.9 billion years ago. From approximately 10.0 billion years ago to 9.9 billion years ago, the universe continued. The evolutionary trends of the previous era, exhibiting even more distinct characteristics. Star formation continued steadily, although at a slower pace, and galaxies that had already formed established themselves as more stable systems. The cosmic web gradually took on a clearer outline, becoming more similar to the universe we observe today. 1. Continued star formation at a slower pace. Although not as explosive as in the early universe, new stars were still steadily born within many galaxies. In particular, active star formation continued in gas-rich spiral galaxies, making their spiral arms more prominent. Newly born stars had various masses and lifespans, playing a role in gradually changing the chemical composition within galaxies. 2. Stabilization of galaxy disks. Spiral galaxies began to maintain their flat disk shapes more stably through rotation. Gravitational interactions and internal dynamics made the distribution of stars and gas clouds within galaxy disks more regular. This subsequently contributed to making the spiral arm structure clearer and stabilizing the circulation of matter within galaxies. 3. Acceleration of galaxy cluster formation. Under the influence of gravity, galaxies gradually began to form larger groups. Small galaxy groups merged to form larger galaxy clusters, and these clusters served as important nodes in the cosmic web. Within galaxy clusters, active gravitational interactions between galaxies occurred, influencing their shapes and evolution. The intracluster space filled with hot gas was also observed to emit X-rays. 4. Increasing influence of dark energy. The expansion of the universe had been ongoing, but it is estimated that the influence of dark energy began to become more prominent during this period. Dark energy is an unknown form of energy that accelerates the expansion of the universe, and after this period, the rate of cosmic expansion increased further. However, between 10.0 billion years ago and 9.9 billion years ago, the influence of dark energy was still in its early stages, and the attractive force of gravity had a greater impact on the formation of cosmic structures. Conclusion. The period between 4.1 and 4.2 billion years after the Big Bang, 10.0 billion years ago, 9.9 billion years ago, was a time when the rate of star formation slowed down but continued steadily. Galaxies acquired more stable structures, and the formation of galaxy clusters accelerated. Furthermore, as the influence of dark energy, which accelerates the expansion of the universe, slowly began to increase. The universe was reaching an important turning point, entering the current era of accelerated expansion. During this 100 million year period, the universe took significant steps towards its current appearance, characterized by more orderly and vast structures. Thank you for watching the Space Story video. Please click the subscribe like notification.